So in this video of chapter number 6, lines and angles, we are going to deal with an important topic, and topic name is parallel lines and the transversal. So we are going to understand what is transversal and how a transversal on a parallel lines creates some interesting different types of angles and their different properties. Now before we move on, let us first see what is the definition of transversal. So I'm going to remove this. Yes. So let's read this out. A transversal is a line that intersects two or more lines at distinct points. Okay, quite simple. I'm going to highlight the keywords. The keywords is two or more lines at distinct points. Okay, so let's try to represent this visually. So for example, if this is one line, okay, and if this is another line, okay, then transverse. Now I'm going to draw transversal with I'm going to draw third line, which will be transversal. So what a transversal should be, it should be a line basically that intersects two or more lines. So here I've taken two lines, but we can take one more. Okay, let's take one more line. In fact, let's say this is one line. Okay, let me change the color. So let's say this is the third line. Okay, so a transversal will be a line that will intersect two or more lines at distinct points. Okay, so now I'm going to draw a transversal, and this will be my transversal. So let me call it T1. Let's call this as transversal 1. Okay, so transversal number 1. Can we have one more transversal? Yes, definitely. We can have as many transversals as possible. So this will be my transversal number 2. So like this. So let's call this as T2. So this is my transversal 2. Why is it transversal? Because it satisfies this property. It's a line that intersects two or more lines at distinct points. Okay. Let's draw one more transversal. For example, yes, let us draw a transversal which will intersect only two lines. For example, something like this. Okay. So like this. Okay, so now this will be T3. So is T3 a transversal? Yes, T3 is also a valid transversal because it intersects two lines at two distinct points. So that was a keyword, two distinct points. Here also two or more distinct points. So as long as it intersects the lines at distinct points, it is a valid transversal. So that's it. That's a very simple, straightforward definition of what a transversal is. Now let's erase this. Now, however, we are focused on transversals that will intersect parallel lines. Okay. In the previous examples, the lines were not parallel, they were intersecting lines, but we are focused only on parallel lines. So, I am going to draw two parallel lines first. So, let's say this is my parallel line 1, this is my parallel line 2, and lines always have these arrows which indicate indefinite extension in both the directions. Okay, so now let's draw a transversal that will intersect two parallel lines. So something like this. So this becomes my transversal which intersects these two lines, these two parallel lines. First of all, let's confirm if this is a transversal. Does it intersect two or more lines at, yes, at distinct points? Yes. So these are the distinct points. Sorry, these are the distinct points, this one and this one. So it is a valid transversal which will which cuts through two parallel lines. Now in this entire chapter, okay, we are just focused on transversal that will intersect two parallel lines. We won't take more than two parallel lines. So in fact, let me update this and let's me just write here two. So two parallel lines, okay, two parallel lines and a transversal. So we'll always have two parallel lines and a transversal. Now if you try to zoom in here, we want to figure out how many angles a transversal is making with the two parallel lines. So this is one angle, this is one angle, this is one angle, this is one angle. Four angles here, and this is one angle, this is one angle, this is one angle, this is one angle. Four angles here. So when a transversal intersects two parallel lines at two distinct points, we get a total of eight angles. Okay. In fact, I'm going to name them so that it's easy to understand. This is 1, 2, 3, 4. Then this is 5, 6, 7, 8. Okay. So overall, we get 8 angles when a transversal intersects two lines, any two lines. It need not be just parallel lines. We are focused on parallel lines. But even if you have non-parallel lines, that is intersecting lines, still the number of angles that the transversal makes with the two lines will always be equal to 8. This is a very important point because going ahead we are going to focus on the properties of these angles, properties of these 8 angles with each other and how they are related to each other. So as of now, the point that we wanted to make was this one. Note. So let's note this point. A total of 8 angles, okay, are formed. Okay, so that was our observation. A total of 8 angles are formed. Okay, so now let's move ahead. And yes, this is already we have a two parallel lines. These are my two parallel lines and a transversal cutting over them. Now we want to see the different types of angles that the transversal makes with the parallel lines. Okay, so types of angles formed by a transversal. A transversal forms total of 8 angles as we saw before. We'll see different types of them, and in the next video we are going to see the properties of these different types of angles and how they are related to each other. But before we go to their properties, we should know what are the names of these angles. So let's see what these angles are one by one. So I'm going to zoom in a bit. Yes, so let's see what is there at A. So first is exterior angles. Okay, now before we go, okay, so we know that there are total 8 angles formed by the transversal. Now we want to see which of these 8 are exterior angles. So I'm going to use a highlighter to note down which are the exterior angles. So this is the first exterior angle, and this is the second exterior angle, and this is the third exterior angle, and this is the fourth exterior angle. So if you ask me to name these angles, so let's say if I call them 1, 2, 3, 4, okay, and 5, 6, 7, 8. These are the 8 angles that are transversal form with two parallel lines. Out of these 8 angles, how many are exterior? 1, 2, and this 7 and this 8. These are the angles which are exterior angles. So I'm going to in fact make a note of it. Which are the exterior angles in this scenario? It's angle 1, okay, angle 2, angle 7, and angle 8. These are the 4 exterior angles of the transversal with the parallel lines. Okay, now let's go ahead and see what is the next type of the angle. Yes, the next type of angle is the interior angle. Now we can guess a bit intuitively which of these would be the interior angles. So I'm going to use a different highlighter now. So this is the interior angle 1, this is the interior angle 2, this is the interior angle 3, and this is the interior angle 4. Once again, there are 4 interior angles. And what are those? Let's name them. So angle 3, okay, angle 4, and angle 5, and angle 6. So we have 4 exterior angles and 4 interior angles. Why are they called exterior and interior? You can be a little bit intuitive about the nomenclature. This is called exterior because they are outside. Okay, they're facing to the outside side of these two parallel lines. And you can see these 4 angles, they are stuck inside. Okay, inside this closed boundaries. These 3, 4, 5, 6 are located. So interior and exterior angles. It's just the name that is given to these angles to refer to them for our future discussions. Now let's go to the third type of the angle, and that is called alternate exterior angles. So we know that these 4, okay, so we know that these 4 are the exterior angles. Now a type, or you can say a subtype of exterior angles, is alternate exterior angles. Now what does it mean? First of all, let's get rid of the highlighted thing. Yes. So okay. So in alternate exterior angles are the pair of exterior angles which lie on the opposite sides of the transversal. Okay, which lie on the opposite sides of the transversal. Plus, they should not share the common arm. Okay, for example, 1 and 2 are exterior angles which lie on the opposite sides of the transversal, but they share an arm. So we should go to, so now let's check 1 and 7. 1 and 7, they lie on the same side of the transversal. So 1 and 8, I'm going to use a highlighter to mark it. So 1 and 8 is a pair of alternate exterior angle. Okay, so I'm just going to note down the okay, first I'll note down the angles, angle 1 comma angle 8, and there's one more pair, and once again we'll use a highlighter to that. So this one 2, okay, and 7, 2 and 7, and angle 2 comma angle 7. So if you, yes, so if you know, if you focus on this four angles that we noted down, so you can see 1 and 8 have got paired and 2 and 7 have got paired. Okay, so once again, what are alternate exterior angles? So they are a pair of exterior angles, okay, a pair of exterior angles which lie on the opposite side of the transversal and which do not share a common arm. Okay, they do not share a common arm. So 1 8 and 2 7 is an alternate exterior angle. Now once again, let's erase this. Now the next type of the angles is alternate interior angles. So once again, alternate interior angles is very similar to alternate exterior angles. They should be on the opposite side of the transversal. Okay, so 4 5 and 3 6, and they should not share this common point. So let me use a highlighter to mention here. So 3, okay, and 6 is one pair, and the other pair is 4 and 5. Okay, so again our interior angle, so there are four, sorry, there are four in, yes, there are four interior angles, 3 4 5 6. So all these are interior angles, but which of them are alternate interior angles? The ones which lie on the alternate side of the transversal. So once again, let's quickly note it. So angle 3 comma angle 6 6, and angle 4 comma angle 5. Okay, so these becomes our alternate interior angles. Okay, so now let's move ahead, and the last type of the angles that are formed by transversal with the parallel lines is called corresponding angles. So in order to understand corresponding angles, we are going to take the same thing. I'm just going to make a copy of it. The copy, let's bring it down, and okay, paste. So this is what I'm going to need, and let's remove the highlighted thing. Okay, now let's try to zoom in. Now, what are corresponding angles? So for corresponding angles, we have to focus on, I'm going to zoom in a bit. Yes, so we have to focus on this intersection as well as this intersection. Look at these two intersections that the transversal makes with the two parallel lines. Okay, now let us say you're standing at this intersection here. Okay, you're standing at this intersection here, and there is one more person who's standing at this intersection. Now if we ask these two people, okay, to look to their left, if you ask these two people to look to their left, what are they going to see? So this person is going to see angle 1, sorry, this person is going to see angle 1, and this person is going to see angle 5. So angle 1 and angle 5 are called as corresponding angles. Why? Because at this position and even at this position, both of them have the same positions with respect to these intersections. Okay, now let's take, now once again I am going to, okay, so first of all, let's make a note of that. So angle 1 comma angle 5. Okay, so let's remove this highlighted thing. Okay, so once again, let's assume there is one person standing here and there is one person standing here. Now if we look to our right side, both of them look to the right side, what will they see? So this person is going to see angle C and this person is going to see angle 2. So with respect to these two intersections, angle 2 and angle C have the same relative positions, and hence they become corresponding angles, angle 2 comma angle C, sorry, angle 6. So I'm just going to highlight them for the sake of understanding this angle and this angle. Okay, both these angles have the same relative positions at these two intersections that the transversal makes with the parallel line. So at both these intersections, both of them are at the right hand side. So that becomes one pair of corresponding angles, same as 1 and 5. Now we are going to erase this once again, erase, and once again we are going to follow the same drill. Okay, let's say one person stand here, one person stands here. Okay, let's use different color. Okay, what do these people see when they look down, when they look towards south and left side? So south and left, So this person will see, okay. So yes, so the first person is going to see angle 3 and the second person is going to see angle 7 to the south and left. So I'm going to highlight them once again. So this, sorry. So this is that angle 3, okay, and this is that angle 7. So once again, what is the specialty about angle 3 and angle 7? They have the same relative positions at these intersections. So they become a pair of corresponding angle 3 and angle 7. Okay. Same goes with, I'm not going to repeat the same thing again. Same goes with angle 4 and angle 8. I'm just going to quickly highlight it. So this is angle 4, which is to the south and to the right. And again, angle 8 is also to the south and to the right. So angle 4 comma angle 8. So in terms of corresponding angles, we have four different pairs of corresponding angles. I'm going to use the highlighter to remove this highlighter thing. Okay. So thus we have got four different pairs of corresponding angles in terms of a transversal and two parallel lines. Just to quickly revise, what are the different types of angles that we saw when a transversal cuts the two parallel lines? First we saw exterior angles. There are just four exterior angles and four interior angles. Then we saw alternate exterior angles. What are alternate exterior angles? This. Okay, diametrically opposite to each other. Then we saw alternate interior angles 3, 6, 4, and 7. And then we saw different corresponding angles 1, 5. Then we saw 2 and 6. Then we saw 3 and 7. And finally we saw 4 and 8. So this completes different types of angles that a transversal makes when there are two parallel lines. In the next videos, we'll see the interesting properties that all these different types of angles have with one another.